This is Mr. Anderson for Keller Community College. We're going to be looking at Chapter 6, which is, Chapter 8, Section 6, which is the quadratic function and the graphs, and we're going to take a look at something called the vertex form. Now, what's important about the way that this worksheet is done is that there's only one graph on it. So what's going to happen is that I'm going to keep working on that one graph, but in class we will probably have some graph paper so we can make multiple sketches. But this is where you're really going to have your calculator kind of help you out a little bit here. So we're going to look at the vertex form and see how that's different than the quadratic formula. Now the quadratic formula, we've been doing this for the last 6 sections here, 5 sections I should say, and that's going to be everything starts out in the form ax squared plus bx plus c, and that's equal to 0. Now, if I completed the square, what this would give me is a different form, and the vertex form is going to be where f of x instead of 0 here is going to be a, the same a is up above there, x minus h quantity squared plus k. This is my vertex form because the vertex is the h comma k. You will notice that the h is being subtracted, so that means my vertex, which is either the minimum of the graph or the maximum of the graph, is going to be the x coordinate h and the k coordinate or the y coordinate k. So this h and k actually shifts the graph horizontally h by the opposite of what the h value is, and vertically k by whatever the k says. The a value is going to be letting me know if it's going to open up or open down. If a is positive, or if a is greater than 0, then the line is going to look like this. Look like a positive smile, and there's going to be a minimum y value at the vertex. Now, if a is less than 0, or if a is negative, and there it shouldn't look like a negative a there, that was a little swipe of the line there. So if the a is negative, then the line will be going down like this, and there's going to be a y maximum at the vertex as well. So this tells you it's going down, so that would be the maximum. This tells you it's going up, so this would be the minimum. Now the h is the horizontal shift, and I'll abbreviate that. The horizontal shift is important because you're going to have to note that there is a negative there. And that negative, that shift is going to be opposite of what the h value is because it's a negative. Now the k is the vertical shift, and that's just the way you see it. This vertical shift is also going to be your max min point. And you're going to see the proper notation used, because for the next 10 problems I'm going to be showing you the kind of graphing I'm going to need, and also how to label the vertex, the axis of symmetry, and the max minimum. So what's important about this here is we are going to, at least for the video here, erase every single problem that I do after I finish it. So I'm going to do problem 1, do the 3 required components, which is labeling the vertex, the axis of symmetry, and the max minimum, and then I'll be erasing that. So you may want to have extra sheets of graph paper available. You can probably put a couple graphs onto this worksheet, but then you're probably going to want to change to another piece of graph paper, and I'll have some public domain grids up in PDF form on the Moodle page that you can download, or as I've always suggested, go out and buy proper graph paper so that way it looks decent when you do your homework. And also another thing about your homework, your graphs have to be plotted points. You can't just do a quick swipe and call that, oh yeah, I'm graphing. No, you're just being sloppy. So make sure that your graphs look great. Alright, so the first equation, and we're going to do the calculator first, that way you can kind of see the answer as I plot them. So let's go to the y equals, make sure that's cleared out. If you click on zoom 6, this gets up a clear screen, and also you want to make sure there's nothing on it and your grid has been reset back to 0, 0, or your window is set to normal. So again, y equals should be clear, zoom 6 to get to to reset your window back to the standard format. Now our first equation is going to be y equals negative. Make sure you click the negative key here by the enter key, and then x squared. So negative x squared, you hit the graph, this is what it's going to look like. I cannot keep this on the screen for long because I have to turn to the table. The table, I really want 5 nice clean points. So let me go to my screen draw here where I'm going to basically plot the points around my symmetry place, because you'll notice that the 0, 0 is that symmetry spot where the other points start moving away in a symmetrical fashion. See, here's 0, 0, here's 1, negative 1, and 2, negative 4, and here's negative 1, 1, and negative 2, 4. 5 points is really what we need to get a good picture of it, but I can fit on 3, negative 9 if I want to, and this is going to give me a nice curve like so. Again, your graph is probably going to look a little better because you're not using a tablet to draw this. Now, the first thing it says here is label your vertex. So your vertex is here, and that vertex is going to be 0, 0. It says then to label the axis of symmetry. The axis of symmetry is going to be a dotted line through the vertex vertically, and the proper notation for that, for any vertical line, it's x equals. So it's x equals 0 because this is a vertical line going through the x-intercept of 0. Then it says find the max and min. Now this problem has a maximum because it's no higher than this big blue dot right there, and my maximum is always going to be a y value equal to however height it is. So you can put f of x is equal to 0 or y is equal to 0, but that's your maximum right there. Your maximum is y equals 0, and your line of symmetry is x equals 0, and your vertex is 0, 0. And that's problem 1. Pretty straightforward. Now we're going to go to problem 2. Let's go to my equation here and type in 3/2 x squared, and then go to graph and take a look at that. Okay, so it looks like the a value is positive, so it's a smile instead of a frown, and we're going to take a look at the points here. Now I like to plot pretty nice, easy to see points, so when I go to my screen draw to draw these points, I'm going to draw some of the easier ones. Like 0, 0 is an obvious easy point to draw, so let me put a dot on 0, 0. Because that's right there. 2, 6 is easy to draw, and since that's symmetrical with negative 2, 6, well, unfortunately got some decimals here, so negative 1 and 1.5, and negative 1, or positive 1 and 1.5. There's my there's my quadratic right there. It looks like my origin is still my vertex, so my vertex is 0, 0. My axis of symmetry, draw the dotted line down there, x is equal to 0 for my axis of symmetry. And my max min, this is going to have a minimum at y equals 0, or you could say f of x equals 0, because that's equal to that as well. And so those are your 3 requirements. And we're going to be doing these 3 requirements for each line. Now, for our third problem, we're going to get into a shift. We're going to get into x minus 1, which is a horizontal shift, not a vertical shift. Hold on, let me get that square there. So this is x minus 1 squared. I'm doing problem number 3. And you can see that this graph got horizontally shifted 1 to the right. So something that you may have thought like, oh, this is going to get shifted to the left. No, since it's x minus h, notice that this got shifted to the right, so it got moved in the opposite direction. So let's go take a look at the table here. Again, I like my tables symmetrical, so I'm going to go from, look at it here. 5 points is really the best way to get the curve in mind. Some of you on one of the first tests only plotted maybe one or like 3 points and thought it was a V instead of a curve, but this is definitely a curve here. So 0, 1 is, sorry, let me start off with 1, 0. Then we got 0, 1 and 2, 1. Then we have 3, 4. And we have -1, 4, and we can even go 4, 9 if we want, and -2, 9 if we want. And there it is. There's my symmetrical parabola right there. Now, my vertex now is not 0, 0. My vertex is 1, 0. There's my vertex. My line of symmetry is x equals 1, and then my this is going to be a minimum. So my minimum is at my f of x, or my y, equals 0. That's as low as it can be. So you're kind of looking at your vertex and taking the first number for your axis of symmetry and taking the second number as your min or max. But you really should know what this looks like picture-wise so you can properly say on the test if this is a maximum or if it was a minimum. Alright, so that was problem number 3. Let's do problem number 4. Problem number 4, in this case, we're going to have a negative in this problem, and then x plus 4. So this is going to, the negative is going to make it a frown, or open downwards. The x plus 4 is going to mean it's going to be shifted 4 to the left. Take a look at that shift from the center of the graph. That shifted 4 to the left. And if we go to our table, I like to put the middle of the table symmetrically, because you'll look at that symmetry right there in the y-axis. And here we go. -4, 0. Whoops, let me click on this here. -4, 0. And then we're going to have -5, -1. -3, -1, -2, -4, and -6, -4, and we can go one more step here, -1, -9, and -7, -9, and here we go. Make a nice tight curve, like so. There we go. That is your upside down parabola with a vertex of -4, 0. That means your axis of symmetry is x equals -4, and your maximum here is going to be where y, or f of x, is equal to 0, because that's as high as a graph is going to go. Alright, problem number 5. Alright, click that in. We're going to have 3x minus 5. Let me retype over that, and this is going to be a shift. The 3 is going to make, this is positive, it's going to make it open upwards, and this is going to shift it 5 to the right. Let's take a look here. There it is, shifting 5 to the right, it's opening upward. That means I'm going to change my table and move to the right a little bit. Now you'll notice that these numbers fly off the graph because of the a value being 3, the numbers just got multiplied quickly. So what that means is that we might have to do just a little bit of extrapolation, because 5 is at 0 there, 6 is at 3, and so is 4 is at 3, but then you've got 3 and 7 at 12, so we're like way off the grid there. Way off the grid, and that's well, I mean, 2 units is not way off the grid, but it's enough to kind of have us guess a little bit. So with this in mind, my vertex is 5, 0. My axis of symmetry is x equals 5, and this is going to be a minimum where y is equal to 0, because there's no number less than 0, or f of x is equal to 0 if you want to put it that way. Problem number 6 is going to make it so that our numbers aren't so big. It's going to kind of widen this out a little bit from our perspective on the screen. So I'm going to put in 1 divided by 3 parentheses. I'm going to, do a third, and then we're going to go x plus 2. And let's go take a look. This is going to be opening upwards. It's going to be looking kind of wide. This is going to be a shift 2 to the left. Let's go take a look. There you go. Boy, this sure beats the old days of just having to plot tables. But let's go to our table here and then build up a symmetric point. The symmetric point is going to be where the 0 is, and pretty points are going to be kind of few and far between with this graph, but I can still graph it pretty well. So I'm going to graph, let's see, -2, 0. So I'm going to put a dot right there, -2, 0. I'm also going to put a dot at -5, 3, and a dot at 1, 3, and the next dot will be at -1 and 3.3 repeating. Oh, wait a sec, 1.3 repeating, I misread that, and also at -4 and 1. I mislabeled that dot there. I'm sorry about that. 0 was supposed to be at 1.3 repeating, and -4 was supposed to be at 1.3 repeating. So there's my parabolic curve, like so. All right, so with that in mind, what I'm going to do here is have my vertex here. My vertex is -2, 0. My line of symmetry is x equals -2, and my minimum point here is going to be at 0, where y is equal to 0, or f of x is equal to 0, since there's nothing below that. All right, moving on to number 7, the last of our horizontal shift problems before we get into horizontal and vertical shift problems. So here we have -2, so this is going to be opening downwards, and then x plus 1/2. Let's insert this 0.5, delete. All right, so this is going to shift to the left 1/2 of a tick mark, so it's going to be about right there, and then it's going to be opening downwards because of the -2. And what's interesting about this is that since we want to see the vertex, we're going to hit, because if we go to the table, we're not going to actually get to see that symmetric point, because you'll see that the vertex is not actually on the screen. Our vertex is shifted a half point, so we should go click second window and change either our start or our change in the table. And it's easier to do the change in the table, so instead of the table moving by 1s, it's moved by 0.5s. Now let's go take a look at our table here, and you can see our symmetry point right there at 0. Let me get that centered up here. So there it is, there's our center point right there. So at -5 at 0, that is where our vertex is, at 0, -0.5. There it is, right there. I'm sorry, I kept saying it the wrong way. Our vertex is at -0.5, 0. Now, again, I'm trying to find some pretty points here, but there's just not a lot. See, I can go to -1.5 and go down to -2. I can go to 0.5 and go down to -2. See, it's still symmetrical, but it's pretty hard to draw these here. This is at +1 down 4.5. This is at -2 and down 4.5. And now let's make our curvy-mervy here. All right, there's our curve. And this is going to be a downwards opening parabola with a vertex at -0.5 or -1/2, 0. Our line of symmetry there, x is equal to -1/2, and our maximum right there is going to be at y equals 0, because there's no point bigger than that, or you could have said f of x equals 0. Okay, so problems 8, 9, and 10, we're finally getting to problems that not only have a horizontal shift, but also have vertical shift. We practiced the horizontal shift quite a bit because it's the opposite of what you see, but the vertical shift is straightforward. See, this is going to be a horizontal shift 1 to the left, and then I'm going to put a +2, which is going to move the graph up. So this parabola moved 1 to the, oh, did I say left? Shoot. I meant this graph moves 1 to the right and then 2 up, because this is going to this -1 here. This is -h, so this is 1 to the right and 2 up. So let's go to my screen draw here. To really hit that home, since I misspoke here, this is going to be my horizontal shift, which is 1 to the right, and I'll put a little RT. Yeah, that does not look like an R. I'm sorry. Now it kind of, yeah, it looks awful. But that's 1 to the right, and this is 2 up. So let's go plot this in place here. And again, I'm going to get rid of this because I'm going to have to go to my table. So it was fleeting, but it was there for a moment. Oh, you know what? Let's go back to our table moving by ones. Just that was second window. Have the table go back to 1 since we're back to using whole numbers. And now here's the thing, you're not going to find that 0 is going to be your symmetry point, but look for symmetry in the table here to let you know you've honed in on that vertex. And I have honed in on that vertex. It's 1, 2. So I'll go back to my screen draw here. 1, 2 is my, gotta click on the right pen mark here. Okay, 1, 2 is my vertex. And now I go 2, 3 and 3, 6. And then on the other side, 0, 3, -1, 6. All right, let's go look at that. There's your nice little swoopy whoop right there. All right, and that's going to be your vertex at 1, 2, which means your line of symmetry, which goes straight up and down through that vertex right there, is going to be, why did I write a parenthesis? X equals 1, and then my minimum point, like the lowest part of this line, and this is going to be a minimum because this is opening upwards, is going to be y equals 2, or you could say f of x is equal to 2. So it's a little different now that you have a vertex that's not on the x-axis. You got to look into your table here where you get that symmetry in your y values here. You see the symmetry? That is to know you've honed in on your y proper vertex there. All right, so let's go do some more work for problem 9. -2. Let's see, x minus 1 is still there, so this is a shift to the right, and then -3. This is going to be shift down, so a shift to the right and then a shift down, and since it's a -2, it's opening downwards. You're getting to kind of assume what these are going to look like before you do them. Let's go to the graph here. It looks like we've honed in on that vertex right there at 1, -3, because the shift was the same in problem 8 and 9. Didn't need to adjust the table there. We will need to adjust the table for our problem 10 here. Our last graph we're going to plot. 1, -3 is right there. 0, -5 and 2, -5. And then 3, -11 is like, well, sorry, 2, let's see here, 3, 2, -5, 0, -5. -1, -11, yeah, it's going to be below the dots right here, so you kind of get this downward parabola. The multiplying by -2 did make the graph move down, but it also made the y values pretty big pretty quickly, so we're not able to plot the fifth points very easily on this picture. But we do have our vertex at 1, -3, which means that my axis of symmetry here, my axis of symmetry is x equals 1, and my maximum here, my maximum y value, is going to be y equals -3, or f of x is equal to 3. Alright, one more problem to go here, and then we're going to do the 2 at the bottom. Alright, so let's go to my y equals here. Let's type in 3/2 in parentheses, or 1.5 would have been equivalent, x plus 2. So this is a shift 2 to the left and 1 down. So 2 to the left, 1 down, opening upwards. There we go. And now let's go to my table. Now let's go and hone in on that since it's 2 to the left, and there's my symmetry right there. I can see my symmetry because the top and the bottom of my table right there is the same. -2, -1 is my vertex. So let's go plot that. -2, -1. There we go. -3.5 and -1.5. I'm just going to have to deal with kind of weird numbers. We got 0 and 5, and we have -4 and 5, and let's go make that happy parabola. Alright, so my vertex is -1, -2, -1. There's your vertex right there in the middle of your screen. And my axis of symmetry, come on you, come on pen. Alright, I don't blame the pen, it was actually my finger holding the button down. X equals -2 is my vertex of symmetry, or axis of symmetry, and my minimum which is the lowest spot on my graph, is going to be where y is equal to -1 or f of x is equal to -1. Now we got two more problems to do in this, and chose to do this all in one video, so thank you for sticking with me for this long. Let's move to the very bottom here. It says, without using graph paper, find the vertex, axis of symmetry, and the maximum minimum value. We've been pretty much doing that even without the picture here, so no graphing calculator. Here we go. The vertex is going to be, in this case, -4, comma, -12, because remember this is x minus h, so this would have to be minus -4. This is why this is a -4, and this is plus k, so that's why this is exactly what it is. Opposite of what it was is what it is, and so there's my vertex. My vertex is x equals x equals -4, y equals -12. So my axis of symmetry is equal to x equals -4, and then my let's see, my vertex axis of symmetry, and then I'm going to deal with my maximum minimum value. Now since this is and my a value is negative here, this is going to be opening downwards, so this means I'm going to have a maximum at my y value of -12, which is another way of saying f of x is equal to 12 at that maximum. Now, things just get weird over here, and the reason why it gets weird is because of the strange numbers here, but don't let it fool you, because the vertex is going to be, see, I've got x minus 0.01, so there's my x value, 0.01, and my y value is going to be square root of 15. See, there's my vertex, and now everything else kind of fits the bill over here. Axis of symmetry being x equals 0.01, and then since the 2 pi is a positive number, this is going to be a smile, so you're going to have a minimum at y equals the square root of 15. Alright, well, thanks for watching, and if you have any questions, let me know, and don't forget to get some graph paper.